Hello, we are going to try some practice questions for SAT circles. So we have already completed the first 9 questions of this worksheet. We'll start with question number 10. So the area of circle is given as 64 pi. QR is the tangent to a circle. So tangent means this will make an angle of 90 degrees. QR is given as 12. We have to find the value of PR. And this OP is the radius of the circle. We can find it. Area is given. 64 pi will be equal to pi into r square. Pi and pi are cancelled. So radius square is 64. Radius is under root 64. That is 8. So this is coming as 8. We can take this as x. So by Pythagoras theorem, x square will be equal to, this is our hypotenuse, opposite to right angle. This will be equal to 8 square plus 12 square. So that is 64 plus 144. So x is coming as under root 208. Now we'll find the factors of 208. All the options are under root 13. So we'll divide it by 13. So that will give us x is equal to 13 multiplied by 16. That is basically 4 into 4. We can take this pair of 4 outside the under root. So x is coming as 4 under root 13. Option B is correct. X is equal to 4 under root 13. Now question number 11. The area of a circle is doubled. What is the ratio of the circle's new radius to the original radius? Say the original area was A. Now the new area is 2A. So if you want the ratio of their radius, so A upon 2A is equals to pi r1 square upon pi r2 square. Pi and pi will be cancelled. A and A will be cancelled. So r1 upon r2 square is 1 by 2. So r1 upon r2 is equal to under root 1 by 2. 1 by root. What is the ratio of the new radius to the old radius? We have found the original radius to the new radius. So r2 upon r1 will be equal to root 2 upon 1. Option A is correct. Then let's try the next question. Question number 12. Find the value of x. Now these both will be the radius. They are both from center to the circumference. So because both of them are radius, this makes it an isosceles triangle. The base angles are equal in isosceles triangle. So if this angle is x, this is also x degree. Now this is a triangle. So sum of all the angles is supposed to be 180 degree. So x plus 100 will give us 180 degree. So we'll have 2x equals to 80 degree. So x is coming as 40 degree. Option C is correct. Now the next question. The diagram, the diameter of the larger circle is 12. The center of each of the 3 concurrent smaller circles lie on the diameter of the larger circle. What is the area of the shaded region? So these are concurrent equal smaller circles. The total diameter is 12. These are going to be, let's take this as small r. Then this is also small r. These two are small r. These two are small r. When we add up all these small r's, we'll get 6 r's. So if you add them up, you'll get 6 r. But this is supposed to be equal to the diameter. So 6 r will be equal to 12. So we can find the value of r. R will be 12 upon 6. That is 2. So the smaller radius is 2. The larger radius, let's take it as capital R. That is coming as 6. Now, what is the area of the shaded region? Area of the shaded region will be area of the larger circle minus area of the smaller circles. So we can calculate that area of the larger circles will be pi into 6 square. So 6 square into pi minus area of the smaller circles. Let's multiply the area by 3. We'll take the area of one small circle and multiply it by 3. So 3 multiplied by pi into radius, that is 2 square. So it's coming as 36 pi minus 3 into 4, that is 12 pi. That will be equal to 24 pi. So option B is correct. It's 24 pi. Next question. The area of the outer square is 256. What is the area of the inner square? Now the area of the outer square is given, so we can find the side of the square because area is equal to side into side. So capital S, or we can take it as S1. So capital S square equals to 256. So side will be equal to under root of 256. That is 16. So the outer side is 16. Now if this is 16, then this part will also be 16. This is going to be the diameter of the circle because the largest chord is always the diameter. This is the largest chord we can fit in. So the diameter is equal to 16. So 2 times radius is coming as 16. So we'll have the radius of the circle, that would be 16 divided by 2. That is 8. We have the radius of the circle. Now the smallest square, it is basically inscribed in the circle. So here we'll use a property that if a square is inscribed in a circle, then the diagonal of the square will definitely pass through the center of the circle, or basically the diagonal of the square will be the diameter for our circle. The reason is very simple, because this is going to make an angle of 90 degrees because it's a square, but circles have a property that semicircle subtends a right angle. So if this is making a right angle, so that means this will be a semicircle. So this particular diagonal will be the diameter of the circle. So we know it's the diameter of the circle. So this is supposed to be 16. So this is coming as 16. We can take this side as x. So this will also be x. So according to Pythagoras theorem, x square plus x square will come as hypotenuse square, that is 16 square. So 2x square is equals to 16 square, that is 256. We'll cancel this 2 with this. So we'll get x square equals to 128. Let's see the option. Oh, it's without option question. So we can directly write this as x equals to under root 128. Now we can break it into factors. So x will be under root of 2 into 64. So x is equal to 64 is 8 into 8. That makes up 8. It can come outside. So side will be 8 root. This is the answer. In this question, all the circles below are concentric circles. So all of them are equal. They have the same radius, and total area of 9 concentric circles is given as 324 pi. The square passes through the center of the 8 circles as shown. So these will be the center of these circles. So that means if this is radius, this is also radius. If this is r, this is also r. First, we'll try finding the radius of the circle. 9 into area of a circle, that is pi r square, is equals to 324 pi. We'll cancel the pi. So we'll cancel 9 and 3, 24. That will give us 36. R square is 36. So the radius is coming as 6. So this is 6. This is also 6. Now we have to find the area of the shaded portion. The easiest way is to break off one shaded portion. And let's go from there. Like we'll break off this shaded portion. We'll join this and this. We are joining from the center. This is the center of the circle. This is the center of the circle. This is the center of circle. So if this is radius, this is also radius. Both of them are 6 and 6. That is 12. Same here. This is also 6. So this will make 12. It's making a square. Now, if you want this shaded portion, so from the area of the square, you have to subtract all of these quarter circles. Why are they quarter circles? Because all of them have a 90-degree angle. You can use the formula also, theta upon 360 multiplied by area. So they will be 1/4 of the total area of the circle. So we'll find the area with the help of this. We'll find the area of one shaded portion. So area is equals to area of the square, that is 12 into 12, minus, we have 4 quarter circles here. So 4 into area of 1 quarter circle, that is 1 by 4 into pi into radius square. 6 square is 36. So these 4 and 4 will be cancelled. So area 12 into 12, that is 144 minus 36 pi. Now, like this, we have 4 portions. We have 4 portions in the same order. So, we have the area of one portion. All of them will have the same area because the circles are concentric. So, the total area will be 4 times this area. So, that would be 144 into 4, that is 576 minus 36 into 4. That is 144 pi. So the correct option is B. 576 minus 144 pi. We'll end this video here, and please remember to subscribe also. Thank you.